Hello everyone, welcome to this class. We are in chapter 2 of our book 1 and we are going to deal with geometry. In this class, we are going to prove some theorem that concerns triangle and their angles. As you can see, we are dealing with triangles and polygons. Please, I would like us to pay close attention to the class because this class requires a lot of attention for you to capture the abstract terms that we are going to be explaining. Let's start. We are referring to the angle plus B cap plus C cap is what? 180 degrees. Now to do that, we added this extra line. This is the base of the triangle. We extended it to X. Now this is one of the sides of the triangle, right? We also drew another line that is parallel to this line. Look at it. Whenever you see two lines in mathematics, especially in geometry, and you see this arrow sign, it means that those lines are parallel lines. So now we've done this, and we now name here A1 and name here B1. This is the triangle we are dealing with. We added this to help us prove our point. So since this is a parallel line and this is also a parallel line, there is one rule. When you have two parallel lines and there is a line joining them, just let me say this is a parallel, this is another parallel line, and there's another line joining them this way. Just know that the angle you have here and the angle you have here is called the alternate angles, and according to geometry they are always equal. This is a parallel. It only applies to parallel line. Don't go and apply it to maybe one line that is not parallel. The two lines must be parallel. So from here you can see that A2 is an alternate angle to A1. Remember what I said. Look at this diagram here. When two parallel line is a line is joining two parallel line, the angles that they form at alternate side. Let me say this is parallel line, this is a straight line, and you have this angle and that angle, like a Z sign. Those angles forming between them are equal. So A1 is equal to A2. So we know that A1 and A2 are equal. The next thing we are going to check, this is also a parallel line, and these two angles, they are called the corresponding angles. You want to know, you just do your hand like this. The angles that correspond, because they are on a straight line, so this angle is doing the same thing that this angle is doing. I think that's how I can explain what corresponding angle means. So corresponding angles are always equal. So in that case, you can say B2 is equal to B1. Now we all know that this is a straight line, and it's a fact that the angle of a straight line is 180. So this angle that form this straight line, which is C2 plus A1 plus B1, will be equal to 180. So let me write it out. C2 plus A1 plus B1 will be equal to what? 180 degrees. Now since A1 is A2 and B1 is B2, so we can also rewrite it as C2 plus A2 plus B2 is what? 180 degrees. And we all know that these angles are the angle of A, B, C. So this proves our point that angle A, which is A2, plus angle B, which is B2, plus angle C, which is C2 here, cap is 180 degrees. So by this, we've proven the first law that the angle, anytime you see a triangle, the sum of the internal angle is always equal to 180 degrees. Let's go to theorem 2. Theorem 2 states that the exterior angle of a triangle is equal to the sum of the opposite interior angle. What it's trying to say, this is a triangle. Exterior angle is when you extend the line out. So in this case, we extended it this side to x. So the angle that is formed when you extend the line out, you can extend it here too, angle will be formed here. You can extend it here too, angle will be formed here. So in this case, I'm using here. This angle that is formed, they are saying that is equal to the sum of the interior angle of the opposite, interior angle. So this is the angle here. The opposite, triangle has 3 sides, 1, 2, 3. Here is not opposite, so see the opposite here. The two angle facing it is the opposite. So you're trying to say that this angle here is equal to this, the sum of these two angles. Let me put it down in notation. This will be ACX. So angle AC, you put cap on C. In this case, you can't just put C cap because we are dealing with, is no longer a converging angle, so we have to express it in letter like in this form, ACX. So we are talking about this angle here is equal to A cap plus B cap. You can see in this case, you can put only A and B because we know that B is just talking about this interior angle. But here we're talking about, you can only say C cap if you're talking about this angle inside here. So we are to prove that this angle is equal to this plus that. Okay. General notation, we know that any angle on a straight line is what? 180 degrees. So it means that this AC cap X, let me put it in this way, this angle plus here plus, allow me to express it in this format too, AC cap B. That's what we're talking about. We all know that because it's on a straight line, the total will be what? 180 degrees. And we also know that this plus this plus this is what? 180 degrees, meaning that this, because this is a triangle and we have already proven it in the first theorem that the total angle of a triangle is 180 degrees. So here plus here plus here is 180 degrees. So let me write it out. A cap angle A plus angle B plus angle AC, this angle here, B, is what? 180 degrees. We know that this is true. This is a straight line, so it's 180. This is a total sum of the angle of a triangle is also 180. So by default, this plus this is 180. This 2 plus this is also 180. So what is missing here? The only common thing both of them have is this. So it means that if you take away, let's say we take away this from the here and this from here, we are left with A plus B, which is by default is equal to this. I don't know if we're making any sense. Okay, let me put it in a notation that is more. Since this is equal to 180 and that is also equal to 180, it means this expression here is equal to this expression here. So let's put it in this form. A angle A plus B plus A C B is equal to also this expression A C X plus A C B. Are we making sense? This is equal to 180, that's equal to 180. That means if both of them are equal to 180, it means both of them are equal to each other. Are we making sense? So by the time you subtract ACB from both equations, subtract this from here and also or subtract this from this side of the equation, you will be left with, oh, I forgot to put the cap. You'll be left with A angle A plus B is equal to A XC So this proves the equation. This is the theorem 2 proven. So indirectly we are saying that the sum of this angle is equal, the external angle is equal to the sum of the opposite angle. Let's say we have external angle here. It means that this angle will be equal to the sum of opposite angle. Let's say we have it here. It means that, let me say we have it here. It means that whatever we have here is equal to the sum of the opposite. So understand what the opposite means. It means the one facing the angle. So let's go to our theorem 1. It even makes more sense from our theorem 1. We said that we're able to prove that A plus B is also equal to B2 plus A2. When we said C plus A1 plus B1, look at it. We're also having the same C. So it means that this angle was actually equal to these two angles when we say that A1 plus was equal to B2. Though this is not what we are trying to prove here, but you can see that logically this external angle is also equal to sum of the opposite interior angle. So let's go to theorem 3. Theorem 3 states that the sum of the interior angle of any n-sided, what do you mean by n-sided? It can be 4-sided, 5-sided, 6-sided. So because we have to do with infinite sides, we represent it with n-sided convex polygon. What do you mean by convex polygon? A polygon that is converging. Let me show you an example. This is a polygon here. As you can see, this is converging. It's converging towards a point, but this is not a convex. You see that this one has something that the shape is irregular. So in this style, we call it a reentrant polygon. But convex is the one that is converging to a point. It's almost like you are drawing a circle, something that is coming. So this rule only applies to convex, doesn't apply for a polygon that is not convex. Say that the sum of the interior angle is equal to 2n minus 4 right angle. Right angle means 90 degrees. And when you are dealing with angle, the another name for 90 degrees is right angle, represented by this sign. You see something like this. Anytime you see something, you know you're talking about right angle, which is the same as 90 degrees. So 2n, the n here stands for the number of sides minus 4 right angle. So let's prove it in this class. So this is a convex. Maybe I didn't draw it properly, but we're trying to say convex. Like, let me say for example, a square is a convex polygon. A pentagon is a convex. You see that it is converging. Unlike when you have something like a star. Star is not converging. So you can't call star a convex. So this law does not apply for figures. It only applies for figures that are coming together. But as you can see, I try to make as many sides as possible. That's why it's almost looking like a circle. The more the side increase, the more it's almost getting closer to circle. So this is a convex polygon of how many sides? It has 1, 2, 3, 4, 5, 6, and so on. So what the law is trying to say is that the total angle that this thing has here, let me say for example, if it's a case of a square, if this is a square, the angles they're talking about is this internal angle. What was this sum of this total angle? If it is this pentagon, we're talking about these angles here. So this one might look somehow confusing because we are no longer we have so many sides here. So these angles, we are trying to find the formula to know the sum of this angle for any n-sided polygon. When we talk about n-sided, we're talking about both 3, 4, 5, 6 side and so on and so forth. So what we are trying to prove is that angle A, which is A, plus angle B, plus angle C, plus and D, E, F, and so on. So let me represent with dot, is equal to 2n minus 4. Permit me to use RA as my right angles because of this illustration I did here. Minus 4 right angles. So it means 2n minus 4 times 90 degrees will give you. So that's what we're trying to prove. This is what this theorem is all about. Now, let's pay very close attention. If you look at this carefully, you see that this is A. This is O. O means the center, the dot, the origin kind of. A, O, B. is a triangle, and we already proven in our previous theorem 1 that the total angle of a triangle, this angle here, this angle here, and that angle here, is 180 degrees. Are we together? So we can say that for this one triangle here, because this pentagon is finally, from this illustration we want to use to prove this, is made up of triangle. This is triangle 1, triangle 2, triangle 3, 4, 5, 6, 7, 8, 9. And if you count the number of sides, you see that it's also 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of triangles is what we are going to take care of in the first step. And now say that one of these triangle, so let's talk about one triangle, will have sum of angles in one triangle is what? From theorem 1, 180 degrees. So if you have to express it as a right angle, is equal to 2 what? Right angles. I don't know if you're making sense. Right angle means 90 degrees. So 2 times 90 will give you 180. So that means if you have to express it as n, I can now say something like sum of angles in n triangle. Now, depending on the number of sides that the polygon has, will be equal to what? Since 1 is 180 right angles, therefore n will be 1 times that 180 right angles. Is like, let me say something like n times 180, right? Is the same thing as n times whatever we have here. So it will be 2n. Here will not be enough, so allow me to use RA, right angles. Are we making sense? So now we've been able to get the total number of angles of this triangle. Now let's take note. What makes up this triangle? Because we are looking for this angle 1, 2, 3, 4 till the number of sides we have. But mind you, when we are calculating for triangle, we're also taking note of this angle here, because we're taking note of this and that, this and that. Now we need to take away whatever we are going to get from this place, so that we know that all we have is just what is at this point, which is what we are looking for, the interior angles of a convex polygon. So now, according to geometry, what is the angle of a dot? Anytime you see a point, it's like a circle. The angle of a point is what? 360 degrees. So let me write it down. Angle of a point is 360 degrees. Is a standard in mathematics. We all know that. So this 360 degree, if we express it as this right angle we are talking about, is equal to what? 90 divided by 360, that's 4 right angles. I don't know if I'm making sense. So what it means is that whatever I get from this n times 180, which is 2 right angles, depending on number of sides, let me say the sides are 10 times 2 times right angle, which is like 10 times 180, which is like 1800. So whatever we get, we'll subtract the angles of this point of the triangle to know that we are only left with only the angles here. So the final answer will now be, remember that this dot is constant. It will always be dot and it will always be 360. So no need to be worried. So the final answer will be 2n minus what? 4. This is 4 right angle. This is 2n right angles. So the common thing both of them have is what? Right angles. So this proves that our theorem that said the sum of the interior angle of any n-sided convex polygon is 2n right angles. So this is what we'll get. This is what we got. So we can express this mathematically. When you want to express it in figure, it will be 2n minus 4 times 90 degrees. So let's try to know if what we are saying is true. Let's start with 3. What has 3 sides? Triangle. So let's try with triangle. Let me write it here. Triangle. The ones that we know, the popular ones that we know, that's the only ones I'll solve and stuff. Triangle and square. We know triangle, we know square, we know rectangle. So triangle has how many sides? 3 sides. So let's replace 3 in this equation. We have something like, then n in the case of triangle is what? 3. So when we replace 3 in this equation, we have 2 times 3. Or let me write it out. Put n equal to 3 in the equation, which is 2n minus 4 times 90 degrees. So we don't get confused. So this is 2n times 3 minus 4 all times 90 degrees, right? 2 times 2, okay, let me put it equal to 2 times 3 is 6, so it's 6 minus 4 all times 90 degrees, which is the same as 2 times 90 degrees, and which is what? 180 degrees. You see, this is correct, because that's what triangle gives us from our theory 1. Another one we know about is square, right? We know that the square and rectangles have 4 sides, and we know that the internal angle is what? 360 degrees from our elementary mathematics. So let's check if it's actually correct. So for square and rectangle, we have 4 sides, right? So 2n minus 4 times 90. Let's put n as 4 in this equation. So we have 2 times 4 minus 4 all times 90, which will give us 2 times 4 is 8. 8 minus 4 all times 90. 8 minus 4 is what? 4. So I have 4 times 90, which will give me what? 360 degrees, which is still correct for what we know about the internal angle of a square. So we can go on pentagon, hexagon. You see that you keep getting the answer. So this is just me trying to prove that our equation is correct. I'll continue with theorem 4 in the next class. So join us in the next class to continue following up. Thank you.